Hello everyone. In this video, I'm going to share my solution in Unit 8 applied to homework. Let's start the problem number 1. Read the scenario first. So, national profiles reported that 10% are high SES, 60% are middle SES, and the 30% are low SES. And Oakwood Elementary School classified that 5 students are in high SES and 55 is in the middle SES and 40 is in the low SES. So according to this information, we could make a table. So expected value is corresponds to the national profile, and observed values are corresponds to the elementary school. So we could put the 100 here and 5, 55, and 40. To make the same total number in the expected value, we set the 100 in total and 10% are high SS, so 10% of 100 is 10, and 60% of 100 is 60, and 30% of the total is 30. Since we have only one category, what kind of test do we need to use? That's correct. This is so because we have only one categorical variable, we can do chi-square goodness of fit test. And as same as the other statistical questions, we need to test whether this is correct or not. So we need 3 steps. The first step is setting the null hypothesis and alternative hypothesis. And step 2 is comparing observed chi-square value and critical value, or comparing p-value versus alpha. We usually set 0.05. And the last step is the interpretation. So let's make a null hypothesis first. Since we want to know that elementary school proportion to the SES are equal to the national profile for SES, we can set null hypothesis as the proportion of SES in both elementary school and national profile are equal. And null hypothesis is a proportion of SES in elementary school and national profiles are not equal. And second step is we need to find or calculate chi-square observed square value or p-value by hand calculation or SPSS. So I will show you how to calculate these two values in SPSS. Okay, this is SPSS data, which is SESdata.sav. We usually saw these columns are consist of numbers, but this is consist of 3 words, that is a high, middle, and low. So even though this is a categorical chi-square goodness of fit test, but we need to let SPSS know that these categorical variables for numeric variables. So I'm going to show you how can we convert these high, middle, low to number 1, 2, 3. So click the transform and recode into different variables, and we need to convert, this is input variable, so I input SES, and I'm going to make an output variable. I will make a new variable name as new SES, and I will label it as this is new SES. And then we need to set high, middle, low to number 1, 2, 3. So, okay, so here high can be converted to number 1, add, and middle value 2, and lastly I will set low SES to number 3, and then continue, and then okay. And I got a new SES variable, and high is the same as number 1, and middle is converted to, and 3, the row is converted to number 3. And let's see the variable view. So here new SES, and the label I set as this is new SES, and we need to set the value as 1 is high, 2 is middle, and 3 is low. Okay, and we need to set this one as a nominal. So we are all set to analyze. So let's to get the chi-square observed value in the chi-square goodness of fit test, go to analyze and non-parametric test, and then go to legacy dialog, and the first one, which is chi-square. Click it, and we need to test this is new SES variable, so I put this one into the test variable list, and we need to set expected value. So if I put the value 10 here and then put the add, it goes 10 first, and then 60, and then I add 60 and 30 into here. So I will erase this one, and then I will show you. Okay, because number 1 is high, so my expected value of the high is 10. So I will add 10 first, and the middle expected value of middle is 60. So I'll put the 60 because national reported as 60% of the person is classified as a middle SES, and the last row SES has 30%, so I put 30 into there. And then okay, and I got the result. So in the result, we have the same frequency tables. So the expected value line, which is highlighted as green, is here. And my observed value, which is elementary school information, this one is here. And test statistic table, the chi-square, this is my observed value of chi-square, and degree of freedom is 2, and this is my p-value. So I know both information, so I will plug it, I will put 6.25 as my chi-square observed value, and p-value is 0.044, 0.044. And we need to know chi-square critical value. Since degrees of freedom is the number of category minus 1, so we have 3 categories, high, middle, and low. So my degrees of freedom is 2, and my alpha is 0.05. So if we find in the chi-square table, degrees of freedom is 2 and alpha is 0.05, my critical value is 5.991. So since chi-square observed value, which is 6.25, is greater than critical value, so let's draw the chi-square distribution. So this is chi-square critical value. So this is 5.99. And after the critical value, this is a rejection area. And my observed value is 6.25. So we reject the null hypothesis. And p-value is less than alpha. We also have a result that we reject the null hypothesis. Therefore, we could say that proportion of SES in elementary school and national profiles are not equal. If you have any question, please reach out to me regarding the problem number 1.